Hey guys, welcome to Level 3 Calculus Complex Numbers paper from 2017. This was actually done during a live stream, so some of the videos might not have the same flow as before. Do apologize about that. Best way to watch this video is to pause the video at the start of each question and have a go by yourself. Yeah, pretty much I go through what you need to do for achieve merit and excellence. So without further ado, let's get started. Cool, so we're up to the first question here. With the first question, what we've been given is u and v is this, find u conjugate minus 3v. So I guess our first step is to have a look at the conjugate of u. Because u is equal to 2 plus 3i, we're just going to have to rewrite the conjugate of u as 2 minus 3i. And we've got 3v, so that's pretty much straightforward. So we've got u conjugate minus 3v, so that's going to be 2 minus 3i minus 3 multiplied by v, which happens to be 1 minus 4i. So expanding the brackets, so we've got negative 3 times 1 and negative 3 times negative 4i. So what do we got? Negative 3 and plus 12i. And this simplifies to negative 1 plus 9i. Nice way to start the paper, especially in 2017. You get an achieved for this question. Okay, cool. Let's go to question 1b. So with 1b, what you got is basically, yeah, rationalizing the denominator and have a go at this question. Cool. So what we want to be doing is, for this question, we want to be rationalizing the denominator. What do I mean by that? That means in the denominator, I no longer want to see the square root of 7. So that means I've got to multiply it by the conjugate of it, which is going to be 5 plus root 7. And in the numerator, I'm going to get 5 plus root 7 as well. So with that in mind, I've got to multiply the 36 with 5, 36 with root 7. So that's going to give me 180 plus 36 root 7. And as for the denominator, you've got difference of two squares. Now you can actually do this in one step. And I know, like, when I teach my guys is that, like, I kind of say to them, like, look, you don't even need to worry about the inside term because you're doing difference of two squares. Because remember, this is like a minus b times a plus b. So this is a squared minus b squared. And pretty much that's what's happening here. So we've got 5 squared. Minus and plus makes minus. Square root of 7 times square root of 7 is just 7 by itself. So with that in mind, our numerator then is going to be 180 plus 36 root 7 divided by 25 take away 7. So 25 take away 7 is 18. And of course, we need to split this up because if you look at the question's actually asking an a plus b root 7. And right now we've got an 18 in the denominator. So we're going to split this up as 180 over 18 plus 36 root 7 over 18, which means we are going to get 10 plus 2 root 7. And of course, the grade for this is achieved. So you do need to get to this part right here because that actually matches the a plus b root 7 form that they're asking for at the start of the question. Yeah, so that's basically an achieved for this question here. Okay, so next we go to question C, which is a merit question. Like calculus papers, surprisingly, they've been doing this nice format of like 2 achieved questions, 2 merit questions, and an excellence. So with that in mind, like this is a merit question right here. And what we need to do is, what are we doing? We're writing x in terms of p. And our first step is, like, we've got to figure out how to get rid of that square root symbol. A lot of people tend to do this straight away. And in this case, it's not really going to help because you've got 0 on the other side. So we want to rearrange it first. So we want to rearrange this as p square root of x minus 2 equals 5 root x. Once we do that, now we can actually square both sides. So when we square both sides, p squared is just p squared, and then square root disappears, which means we've got x minus 2 left here. And then 5 squared is 25, and then square root of x is just x. Our next step is, of course, expanding the brackets, because we are trying to write x in terms of p. So we want to have x by itself. So we've got p squared x minus 2p squared equals 25x. I want to bring that x, 25x, to the left-hand side. So I've got minus 25x, which is all equal to, of course, I'm going to take the 2p squared to the right-hand side, which is going to make it positive 2p squared. Let me just write that in a different color so you guys can see what happened, that the symbol actually changed. Then I've got to take x here as a common factor. So I take out x as a common factor. I've got p squared minus 25 equals to 2p squared. And then x is equal to 2p squared over p squared minus 25. So grades-wise, what you're looking at is a merit grade for the final proof. Correct expression without surds gets you an achieved. So I would say this line right here gets you an achieved. So again, if you think about time-wise, I mean, like question 1B took a little bit longer than, I don't know, maybe it took around the same time. But yeah, that's basically question 1C. Okay, so with this question, it's been coming for the last few years, right? Like pretty much every year, a variation of this question comes. And I know that if you guys have a look at my 2018 and 2019 papers, I would have done it slightly different. And in today's version, I'm gonna do it slightly different. I'm gonna do this entire thing on the graphics calculator with just minimal rearranging, all right? So the first thing to kind of understand here is we've actually got a solution that's already been given to us. So negative 2 minus I. So in other words, what I could do is I could say, because it's a solution, then negative 2 minus I cubed minus 2 times negative 2 minus I squared plus b times negative 2 minus I minus 30 is equal to 0. Now, looking at this thing here, yeah, sorry about that. Just got a little bit delayed there with the... Anyway, so what we know is that because that negative 2 minus I is a solution, I'm literally going to just, put that all in there. And, you could actually work this out. Again, you can do this in the calculator in one shot. And that's what I'm going to show you guys today. So the idea is this. All right, before I actually put it on the calculator, what I'm going to do here is I'm going to rearrange this. And I just want to rearrange this slightly in a different way so that you guys can actually see what's happening here. So what I'm going to do is I'm going to leave BZ here, and I'm going to take all of the other terms to the other side. So I've got 30 plus 2z squared minus z cubed. Then I can say that B is equal to 30 plus 2z squared minus z cubed divided by z. All right, and the reason why I did this is because, like I said to you guys, I'm going to use the calculator to try and do this in like one shot. So that right there is negative 2 minus I, that's negative 2 minus I, and that's negative 2 minus I. Really good idea is to put a bracket around this. So here comes the magic, all right, to try and do this as fast as possible, because you want to save time in your exams and you don't want to be like making silly mistakes with this. So what I would do here is I go minus 2 minus I, and I just put that as equals. So basically what this does is in the calculator, it actually stores as the answer function. All right, so anytime answer is pressed, that's what it's stored as. So the next step is I'm going to go 30 plus 2 times answer squared, because that's what the answer was, negative 2 minus I, then minus answer cubed, because that was z cubed, and then divided by z, which in this case is answer. And if I click on it, I'm going to get b is equal to negative 19. And pretty much that's all that you guys need to kind of show there. So you've shown that you've substituted z to find out what b is. Because like really you don't, like there's so many ways in which you can actually do this question. But yeah, that's pretty much the first part of this question here. So just showing what b is, the b is equal to negative 19. Now, the next part of the question is trying to figure out the other two solutions. Our first solution is already given, which is minus 2 minus I. Our second solution is going to be the conjugate of it, so negative 2 plus I. Now we need to figure out what that last value is. And the way we're going to do that is, remember, like if we do Z1, sorry, not Z1, Z minus Z1 times Z minus Z2 times Z minus Z3, it equals to basically this part right here. Z cubed minus 2Z squared. We've figured out what B is, which is minus 19. Z minus 30. But the only thing that we are really interested is the constant, which is minus 30. Because we know that negative Z1 multiplied by negative Z2 multiplied by negative Z3 equals to negative 30. So that's what we're going to do here. So we've got negative Z1, which is minus 2 minus I, multiplied by negative Z2, which is negative 2 plus I, multiplied by negative Z3. Now, we don't know what negative Z3 is, but we don't know what Z3 is, so we're just going to leave it as that is. So next step is we can actually go negative Z3 equals negative 30 divided by negative 2 minus I multiplied by negative 2 plus I. So once again, I'm going to go to the calculator and I'm just going to chuck it on in the calculator and make sure it's not that. So I've got negative 30 divided by, I'm going to open up a bracket, minus what I've got, negative 2 minus I, negative 2 minus I, and then multiplied by negative 2 plus I. I hope that's all the correct calculation there. And what I've got here is negative Z3 is actually equal to negative 6. So then I can say that Z3 equals to 6. So my all my solutions are negative 2 minus I. Second solution is negative 2 plus I. Third solution is positive 6 right there. So grades wise, what we're looking at is you have to get both negative 19 and the other two solutions. So you have to get this and negative 19 for a merit. But you could get an achieved if you get either negative 19 as B or one of them to get an achieved. Yeah, a bit of a standard question. And I know like I've done this question like lots of different ways in the last few years worth of exam papers. So a lot of different strategies that you guys can try for this type of question. But ultimately, I think what we're looking for in the answer schedule is that the two final answers correctly given. Cool. So with question 1E, anytime you guys see a locus question or a Cartesian plane, we always remember that z equals to x plus iy. And also remember that the modulus of x plus iy is actually equal to square root of x squared plus y squared. Now this two things is a must know for any type of locus questions, because it's just like, yeah, those are your two key things that's going to help you solve this question. So what am I going to do here? I'm going to replace the z with x plus iy. So I've got x plus iy plus 2 minus 7i is equal to 2 x plus iy minus 10 plus 2i. So this is what I've got so far. My next step is to collect all the real parts and the imaginary parts. So here I'm going to get x plus 2 plus y minus 7i equals 2 times x minus 10 plus y plus 2i. So at this point, I can actually use the modulus equation and get rid of those two lines. And I'm going to replace it with x plus 2 squared plus y minus 7 squared equals 2 times x minus 10 squared plus y plus 2 squared. So far, so good. Next thing, I need to get rid of the square root symbol. So I've got to square everything. And when I square everything on the left-hand side, the square root symbol disappears nicely. So I don't have to worry about it. But on the right-hand side, I've got the 2. So that's going to become 4 multiplied by x minus 10 squared plus y plus 2 squared. Now, here's the thing. We don't have a choice. We've got a ugly as long quadratic equation that we've got to expand, and we've got to rearrange, and we've got to complete the square and somehow bring it to this format right here. All right. Now, remember this. If you can get actually up to here, then there's a very good chance that you're going to get at least a merit, because all you have to do at this point is expand and rearrange, collect all your like terms, and you're pretty much good to go, right? So that's what I got to do here. And bear with me, guys. It's going to take a bit of time. So what do we got? We got x squared plus 4x plus 4 plus y squared minus 14y plus 49 equals 4 times. I'm going to keep all of that inside because then it's just easier for me to expand out. Minus 20x plus 100 plus y squared plus 4y plus 4. And I guess this is the part where I have to actually expand it out. Why do they give us this long questions? And I guess that's why you kind of need like 10 minutes to kind of like go through these questions. So 4x squared minus 80x plus 400 plus 4y squared plus 16y plus 16. And here's a little trick, all right? And this is a bit of a cheap trick, but it does work in this case anyway. So I'm going to make the left-hand side 0 because I want to rearrange everything. And what I'm going to do is kind of write all those terms underneath it, because x squared is right here. So that's minus x squared minus 4x minus 4 minus y squared plus 14y and minus 49. Hope I got that right. Yeah, let's see how that goes. So now I can actually easily eliminate it, because then I can write it as 3x squared minus 84x. I've got plus 400, 396 plus 3y squared plus 30y minus 49. No, not 49. Oops. 16 take away 49. See, this is what happens. Like late into the night, my head just starts. Don't want to make mistakes in this. So minus 33, and I'm just going to do that 396 minus 33 to give me 363. So what I've got here is 0 is equal to 3x squared minus 84x plus 363 plus 3y squared plus 30y. Now, looking at all these numbers, I can see that 3 is a common factor. So I'm going to take 3 out. So I've got 84 divided by 3, which is 28. 363 divided by 3 is 121 plus y squared plus 10y. I can get rid of the 3 now because 0 divided by 3 is just 0. So I'm going to get 0 equals x squared minus 28x plus y squared plus 10y plus 121. Now, this is where I need to complete the square. So what I am going to do is I'm going to rewrite this now, x squared minus 28x plus y squared plus 10y plus 121 equals to 0. I'm going to move that 121 to the other side. Just bear with me, guys. If you have forgotten completing the square, it's not too difficult, all right? Because I'm going to show it to you in like one shot here. So to complete the square, first off, I'm looking at that negative 28. All right, so I'm going to do negative 28 divided by 2. Let's delete all of that. Negative 28 divided by 2 is going to give me that, and I'm going to square that. So negative 14 squared is 196. So all I got to do here is I'm going to add 196 to, let me just put that in a different color. This is how you complete the square. I'm going to add 196 here, and I'm going to add 196 here. Next, I'm going to look at the 10 here, and it's positive 10. So 10 divided by 2 is 5. 5 squared is 25. So I'm going to add 25. And on this side, I'm also going to add 25. So with that in mind, here I'm going to get x minus 14 squared plus y plus 5 squared equals 196 plus 25 minus 121 equals 100. And basically, guys, I've actually done that question. Yeah, that's pretty much it. That's how you do the completing the square. And you're done. So grades wise, what are we looking at? Excellence for the final proof part of it. So that's the last bit right there. Now for a merit correct equation for x and y without surds, for merit correct equation for x and y without i's or surds. So you're looking at a merit. Wow. Really? Up to here? I'm looking at the exam schedule. I'll show you guys what I mean by, where is it? Now check out this. Correct equation for x and y without i's or surds gets you a merit, which means that's this line right here. That line right there is correct. Yeah, that's got no i's or surds, so that'll be a merit. There you go. And of course, achieved is correctly separating the real and complex components on both sides. So that would mean separating it is about here, is where you're looking at an achieved. So yeah, like I said to you guys, this question here, while it's long, but it's a proof, like it's a question where you know you're going to get an answer, and it's a nice answer, which means, yeah, just got to keep persevering at it, and kind of keep going till you get that answer. But yeah, that's basically it for question 1, guys. Now we go to question 2. All right, guys. So with question 2A, what have we got here? So we're going to try and figure out the value of D, and if this, what do you call it? If this quadratic, no, cubic is being divided by x minus 3. So basically what it means is that we can say remainder theorem states that f of 3 in this case is equal to 13. So all I got to do is I just got to substitute 3 wherever x is. I've got minus 2 3 squared plus 5 times 3 plus d equals to 13. So 27, take away 18 plus 15 plus d equals to 13. Yep. That's pretty much it. So 27 take away 18 plus 15 gives me 24. So 24 plus d equals 13. D is equal to 13, take away 24, which equals to negative 11. So question 2A is worth and achieved, and you got to have the correct solution. No negotiations. Yeah, that's question 2A. Going to question 2B. So it's asking us to simplify as far as possible. So all we got to do is just expand this brackets and get rid of the square root symbol. So we got square root of 2k multiplied by, let me just write the question first. So treat it exactly like how you do it with expanding a bracket. So inside here, we're going to get 18 times 2, which is 36. So that's 36k squared, minus square root of 8 times 2 is 16, 16k squared. So 36k squared is 6k, 16k squared is 4k, and you're going to get 6k minus 4k, which gives you 2k, also worth and achieved. Yeah, just kind of like powering through these achieved questions. Okay, so the next question that we have here There is a couple of ways of doing this. What we could do is we could actually find out the argument of Z first. Then we could find out the argument of ZW. Um, and then we could use the argument rules to actually figure out what it is. That's one way of doing it. Or yeah, we could find out actually what W is first. So that's what we're going to do here. So we're going to say that W is equal to ZW over Z, which equals to 15 minus 3i divided by negative 2 plus 3i. Now, here's an interesting thing, right? And I always kind of go, you could, I mean, like, you could just use the calculator for this, right? Because, like, think about it. Because you got 15 minus 3i, I'm going to put that in there, divided by negative 2 plus 3i. And it gives me minus 3i, right? But just to be on the safe side, just to keep the markers happy, I'm going to do conjugate, multiply by its conjugate. So negative 2 minus 3i divided by minus 2, 3i. And then I'm just going to go w is equal to minus 3 minus 3i. Because, you know, I've shown that I understand what I'm doing here, but I'm not going to sit there wasting my time doing all those little calculations for a merit question. Now I need to figure out what the argument is. So I'm going to kind of like draw this real quickly. Minus 3 is somewhere here. Minus 3i is somewhere here. So the complex number looks like this, which means the angle that it's going at is, what is it, 90, 180, and then half of that, so 225 degrees. So you could actually just put your argument in 225 degrees. So I would actually put down argument of W is 225 degrees. But of course, you could also put that in radians. So you might have it as 5 pi over 4, because pi over 4 is 45 degrees, and 5 times that is 5 pi over 4. So grades-wise, correct expression for W and correct argument for W as an exact value gets you a merit. A correct expression for W gets you an achieved. Cool. Moving on to the next question. Right. Complex roots, one of my favorite things. Um, and I know I say this in every exam, and I always forget to put the link towards this. So again, if somebody is there, if you just kind of look in the 2020 complex numbers paper, one of the students actually asked the same question. He's talking about this tutorial video on polar complex roots. Go to that video. In the comment section, you're going to find a link. If not, someone remind me and I'll actually put a link up later on. But yeah, let's go through this question. So with complex roots, the first thing I really need to do is convert it to polar form. Once I convert it to polar form, then I use de Moivre's theorem. I get my first root and then just add 90 degrees all the way up, right? So as I said, go watch that tutorial. But if not, if you watch it and you're kind of like, yep, I'm kind of happy to go on, this is how you do it. The first step that I always do with these complex roots questions is I've got to actually kind of like draw it out because it just makes so much more sense for me. M over root 2 is somewhere here, and then M over root 2 is somewhere there. Straight away, I know that this is going to have an argument of 45 degrees. The reason it's going to have an argument of 45 degrees is because the real is equal to imaginary. So that is all good. That's the argument. As for the modulus, if you remember, is r squared is like a squared plus b squared, or x squared plus y squared, whichever one you want to call it. So in this one, it's going to be m over root 2 squared plus m over root 2 squared. And because it's r squared, r is equal to square root of all of that. So that's the modulus, which means I'm going to get m squared over, what is it? Square root of 2 squared is just 2, plus m squared over 2. So r is equal to square root of 2m squared over 2. R is equal to square root of m squared, and r is equal to m. So basically what I've done is I've said Z4 is equal to m cis 45 degrees. All right, now you might choose to work in what do you call it? You might choose to work in radians. That's absolutely fine. So that's my first thing, right? Now also the other thing that I always talk about is this. When you actually have Z4, that basically means that you're going to have 4 answers. And because you have 4 answers, they're going to be split up. Each of the answers is going to be separated by 90 degrees. So if you find that first root, then you can just add 90 degrees to the remaining answers to get the remaining answers. So that means your first root is going to be m cis 45 to the power of quarter. So Z1 is equal to m to the power of quarter cis 45 times a quarter. 45 times a quarter, let's just go back to the calculator. That gives me 11.25 degrees. So Z1 is equal to m quarter cis 11.25 degrees. Just want to try something here. 180 divided by 16. Yeah, so the what do you call it? The radians version is actually pi over 16. But anyway, look, we've figured out what our first root is, which is 11.25. And so we can pretty much work out what all the remaining 4 roots are. And this is my cheat way of doing this. It works. There's nothing wrong with it. All I'm going to do is 11.25 plus 90, which is 101.25, plus another 90, 191.25, plus another 90, which gives me 281.25. That's basically it. And again, I would strongly recommend you guys to go and watch that little video that I put in the comment section of the 2020 complex numbers paper. Grades wise, all 4 solutions here gets you a merit. 1 correct solution gets you an achieved. 1 correct solution gets you an achieved. So that's like that right there gets you an achieved, or gets 4 arguments, which is like 4 angles. If you get the angles correct, you get achieved as well for that. Okay, that's basically it for this question. We move on to the next one. Okay, so with question 2e, what we're trying to look for is values of k that makes this purely a real number. Now, as I said before, and I'm kind of just repeating myself here, but purely real number means the imaginary part is equal to 0. And likewise, if you have purely imaginary number, then the real part is equal to 0. So all we got to do with this question is we've got to manipulate this equation or this statement and separate the real and imaginary part. That's all we got to do. All right. So pretty much what we've got here is if u equals k plus 4i divided by 1 plus ki, I'm going to rationalize the denominator, which means I'm going to multiply by 1 minus ki and the numerator by 1 minus ki. This is going back to question, I think, what was it, 1a or 1b that we did, rationalizing the denominator. That's all we're doing here, which means now the numerator ends up being a quadratic. So I've got, basically doing the, well, whatever you want to call it, FOIL first, it doesn't matter. Just expanding the brackets. I've got k minus k squared I plus 4i minus 4ki squared. And all of that is divided by difference of 2 squareds. So it's going to be 1 squared, which is just 1, minus k squared I squared. So with that in mind, in my numerator, I've got k, what do we got? Minus, okay, so this part right here, remember that I squared is actually equal to negative 1. So negative 1 times negative 4 is going to be 4k. Negative 1 times negative 4 is plus 4k. And in here, I've got minus k squared I plus 4i. All of that divided by 1 plus k squared. So far, so good. Now I need to separate into real and imaginary. So my real part is going to be k plus 4k, which is 5k. So that's 5k divided by 1 plus k squared. And my imaginary part is going to be 4 minus k squared I divided by 1 plus k squared. So all I've done is I've just separated the real part and the imaginary part. Now I'm going back to my question. If the number is purely a real number, then the imaginary part is equal to 0. So this entire thing right here is the imaginary part, and that is actually equal to 0. So I've got 4 minus k squared over 1 plus k squared is equal to 0. And I'm just going to write that at the top here. Imaginary is equal to 0. And what I've got, cross multiplying, I'm going to get 4 minus k squared is equal to 0. And then rearrange it. So k squared equals to 4. Therefore, k is equal to, and really important for this part, is that you actually do square root of 4, which is actually going to give you plus or minus 2. And by the way, if you forget the minus, according to the paper, it says correct values of k. So you actually have to give both plus and minus values. It doesn't say anything about E7. So if you don't get that plus or minus, it's a bit harsh, but I think it might be a merit up to this level because they don't actually show, oh no, 1t with minor errors. So yeah, it might be possible that you get an E7 for it if you just put a plus 2. So both E8, positive 2 is going to get you only an E7, I would say. Correct expression for u with a rational denominator. So that's going to be achieved, which is here. This line here is going to get you guys an achieved. Yeah, so it's one of those excellence questions where you know what you're working towards. And time-wise, you can kind of like see, okay, this is how much time I'm going to spend on it. And even explaining it, I think it only took me like 5 minutes to do this problem. So if you think about it, if you want to spend like 10 minutes for an excellence question, not bad. You're going to save a bit of time with these types of questions. Moving on. All right, guys. So question 3a. We got two complex numbers, and we got to do u over v. So all we got to do is u divided by v is the same thing as saying p cubed divided by p, cis pi over 3 minus pi over 8. So p3 over p is just p squared, cis pi over 3 minus pi over 8. Now, if you're like, oh man, I really don't want to be sitting here doing fractions, shortcut, as always. What do? Forget about the pi and just go 1 over 3. So 1 over 3 minus 1 over 8. That's 5 over 24. So you just write that number down, 5 over 24, and then just put the pi at the end. Okay, why did I do that? Because pi over 3 minus pi over 8 is the same thing as saying pi multiplied by 1/3 minus 1 over 8. So that's all I did there. It's just a quick way to do these questions so that you're not sitting there wasting time on doing fractions in a high stakes exam. And of course, you're guaranteed to get that right answer as well. Cool, grades wise achieved. Moving on to the next one. Okay, 3b. What do we have here? So give you a solution. So this one, unfortunately, we don't have a choice. We just got to use the quadratic formula and get this done. So we can actually go, is there another quick way of doing this? I'm trying to think. No, I'm just going to use the quadratic formula. So A is equal to 1, B equals minus C, C is equal to 14. And then I'll just take down my quadratic formula, which is x equals minus b plus or minus, what did I do there? B is equal to minus 6. Minus b plus or minus b squared minus 4ac over 2a. So I've got negative of negative 6 plus or minus negative 6 squared minus 4 times 1 times 14 divided by 2. So I've got 6 plus or minus. And inside the square root, I'm just going to put all of this in the calculator. So I've got negative 6 squared, which is 36, minus 4 times 14. So that's going to give me negative 20. And that's all over 2. So I got to take out the negative 20, and I'm going to rewrite that as 20i squared, because remember that I squared is equal to negative 1. Now, I'm still not getting to that a plus bi format. So what I've got to do is 6 plus or minus. Square root of 20 could be written as 4 times 5i squared over 2. Then I can separate the 4, square root of 4, times square root of 5i squared. In fact, I'm going to separate all of them just so I can show you how this question actually works out. So I've got 6 plus or minus, square root of 4 is 2, square root of 5, I can't do anything to it, multiplied by square root of I squared, which is I, and that whole thing is divided by 2. So I've got 6 over 2 plus or minus 2 over 2 square root of 5i, which gives me 3 plus or minus root 5i. Yeah, a bit of a hell of a lot of working for an achieved question, but that is what we're looking at. Now, if you want to check whether you are on the right track, what you could do is you go to your calculator, set up your calculator. Where is complex mode? Complex mode, you click on a plus bi. Then what you could do is go into graph, no, not graph, where is it? Equation, and click on polynomial, degree 2, and we're going to literally put these numbers in here, 1, minus 6, and 14. The only problem is, yeah, it's going to give it to you in decimals, so you got to try and remember that number, and that's one of the reasons why they kind of make sure, if you look at the question, they actually say this in the question, A and B are rational numbers. All right, so that's something to keep in mind. Anyway, that is worth an achieved, and a lot of working for an achieved question, but it is what it is. So let's go to the next one. With question C, guys, like, right now, I'm trying to think of an easier way. You might have done it with long division. You might have done synthetic division. Your teachers might have given you other strategies to try and work that out as well. Unfortunately, the only way that I'm going to show you guys in this case is long division. But yeah, we just have to have a kind of go at it. I have made long division videos in complex numbers playlist. So if you go and have a look at the complex number skills playlist, which should pop up at the end of this video, have a look at how to do these types of questions with long division. So I'm going to start off. I've got x plus 2. And I'm going to write everything down. 3x cubed plus 8x squared minus 2x plus 11. So then I'll write it in different colors so you guys can see what's happening, right? So first I'm going to multiply by 3x squared, because 3x squared times x is 3x cubed. 3x squared times 2 is plus 6x squared. Now I've got to subtract them. So 3x squared cubed minus 3x cubed is going to be 0. 8x squared minus 6x squared is 2x squared. And I'm going to bring this minus 2x down. Now I'm going to multiply it with 2x, so plus 2x. So 2x times x is 2x squared. 2x times 2 is plus 4x. And once again, I've got to subtract them. Negative 2x minus 4x is equal to minus 6x. And I'm bringing down the 11 now. And I'm going to multiply it by minus 6. So I'm going to get minus 6x. Minus 6 times positive 2 is negative 12. And what I'm going to get is a denominator of 11 minus 12, which equals to 23. So I basically have, just going to write this in a different color, 23. So 23 is the C. The B value happens to be negative 6, and the A value happens to be positive 2. So I'm just going to write that down here. A equals 2, B equals minus 6, C, which is the remainder, which equals to 23. So for merit, all three. For achieved, I'm going to put down need 2. For merit, you need 3. Yeah, so I would recommend you guys to go check out those long division videos that I put up. That's the one way I know how to do these types of questions. I wish I knew another one, but what's another one you could potentially do? You could use remainder theorem to try and figure out C, but it still doesn't give you A and B. It's a bit of a pain. Cool, let's go on to the next one. Okay, so with question D, what we've got is, oh, right, we just got to rewrite x equals a plus b root 3. Okay, so what we're going to do is we're going to cross multiply here. So we're going to get 8 plus x is equal to root 3 times x. We want to have x by itself. So I'm going to take the x, no, I'm going to leave the x here. So I'm going to bring the square root of 3x to the left-hand side. And I'm going to move 8. I don't think it matters, does it? No, it wouldn't matter. Let's go negative 8. Then I'm going to take x as a common factor out. So x is going to be taken out. I've got x minus root 3. No, 1 minus root 3 equals negative 8. And then x is equal to negative 8 divided by 1 minus root 3. Now the problem is they want it in this format, a plus b root 3, which means I need to rationalize the denominator. I'm going to multiply by 1 plus root 3. And when I do that, I'm going to get x is equal to negative 8 minus 8 root 3. Because remember, this is kind of like multiplying by that and that. And then in the denominator, I've got difference of 2 squares. So I've got 1 minus root 3 times root 3 is just 3. Because remember, this is the same thing as saying in the denominator, a minus b times a plus b is a squared minus b squared. That's all I've done there. Then I've got x equals negative 8 minus 8 root 3 divided by negative 2. I still got to get rid of the negative 2. So I've got negative 8 divided by negative 2, negative 8 divided by negative 2, root 3. So this is going to become positive 4 root 3. There's a few different ways of doing this particular question, but yeah, that's pretty much it. Solution-wise, grades-wise, merit for this part here, solution with non-rational denominator, non-rational denominator. So somewhere here, it's probably looking at an achieved. 1, 2, 3, 4, 5, 8. 2, 3. Sorry, I'm just having a look at the answer schedule, guys. No, made a mistake. Sorry. I think achieved is actually here. That part before even rationalizing it. Cool. So just going back to this question, what we've got here is we've actually got z, which we need to substitute into that z and that z. Basically, you're going to end up with a super, super ugly equation that you have to somehow manipulate. So this is my super ugly equation. Oh, I forgot the 2 times that as well. A plus bi divided by a minus bi. Cool. Somehow, I've got to manipulate this to equal that. All right. Now, look, that you know, given the time, yeah, you probably can spend quite a bit of time kind of like working through it. But like I was mentioning earlier, that I'm going to try a slightly different method here. And what I'm going to do is I'm going to try this method here. I'm not going to get, how do I say this? I'm going to try separating this and see if that's going to make it slightly easier or not. So all I've done there is I've separated the z squared and the 1 into 2 separate fractions, right? Because theoretically, I could cancel out 1z and z, and what I have is z divided by 2 plus 1 over 2 times z. What would happen if I substitute z now? Because I'm going to get a plus bi divided by a minus bi. And remember, z over 2 is the same thing as saying half times z. So I've got a half multiplied by that. Is it going to make any difference is what I'm trying to figure out. Plus 2z, so plus 1 over 2 times z, which is going to be a plus bi divided by a minus bi. And because of this being a fraction, 1 over that, I could literally just flip it over. So it's kind of like this. If I have 1 over 3 over 2, this could be said as 2 over 3. So that's all I'm going to do here. I've got a half multiplied by a plus bi over a minus bi, plus a half times a minus bi, because that's now in the numerator, divided by a plus bi. Okay, this seems interesting so far. I'm liking it so far because like it kind of starting to make sense. Now what I got to do is, because I've got two halves, I'm going to take the half out as a common factor, and I'm going to bring it back much later. Right now I'm just going to focus on this, which is a plus bi over a minus bi, plus, not multiplied, plus a minus bi divided by a plus bi. And I'm leaving this space here for a particular reason, because I am going to multiply by the conjugate of it. So I've got a plus bi and a plus bi, and then multiply it with a minus bi divided by a minus bi. Okay, so far, so good. This is looking promising, actually. In my denominator, because I've got a plus bi squared here, I'm going to expand the brackets, so I'm going to treat this as a quadratic. So multiply that and that, that and that and that and that, whatever that's going to be. So it's going to be a squared plus 2abi plus b squared I squared. And that whole thing, remember they all have the same common denominator, which is a minus bi multiplied by a plus bi. And the next part, I've got to do these ones. So I've got to go that multiplied by that, that, and that, which is going to give me a squared minus 2abi plus b squared I squared. Now this is looking very promising, actually. So half, and I've got a squared plus a squared, which is 2a squared. That's a squared and a squared. Then I've got 2ab and minus 2ab disappears. Then I've got b squared I squared, b squared I squared. So that's plus 2b squared I squared. Divided by, we got a difference of two squares there. So that's just going to be a squared minus b squared I squared. So far, so good. And I've got a half. I can take the 2 out as a common factor. So I'm going to get half times 2. And in the numerator, I've got a squared plus b squared. And I squared is equal to -1 divided by a squared minus b squared minus 1. Now 2 times half disappears because it's just 1. And in the numerator, I've got a squared minus b squared divided by a squared plus b squared. Now, this is not the conventional way of actually going about proving this, but you know what? I don't know. I just saw this. I thought, why do I have to do the regular method? Why don't I try doing something like this? And guess what? We are still ending up with that same proof there. So grades wise, what we're looking at is correct proof is going to be an excellence question. Sorry, excellence for the correct proof. Merit is, this is where things get tricky because I did an alternate method. There's like 2 methods that they've given in the answer schedule. I'll show you guys. So the first method is that one there, which is well, it's still ugly, it's long, um, and yeah, it's just like lots of different ways. Like obviously, there's like three different ways of doing this. Here's another way they did this. Um, and again, but they all had that same starting point of the left-hand side. They all did what we did right at the start. But I kind of changed it towards the end. So the merit part is where they said is like somewhere here, and achieved was there. Where are we going to go? Main recording again. Yeah, so we're just kind of like going through the different variations. So with this one, the first trick was to kind of separate it. So that was trick number one. Trick number two is right here, is understanding that when you actually divide by a fraction, you can rewrite this. Someone asked in the chat there, is half 1 over 2z is, no, it's not the same as 0.5z. Half z, this is equal to 0.5z. All right, the z is actually in the denominator. So in this case, I saw that a plus bi in the denominator, and I knew straight away I could do something like this, which would actually flip it over. Yeah, it's a good point, Simon, because yeah, it's really easy to make mistakes, especially when you're working with Z and 2, that you can actually kind of like mistake your own handwriting for Z, for 2 as a, or mistake Z as a 2 or a 2 as a Z. Even my half times Z there is quite not any better right there. There we go. Probably should do that more often. Yeah, so it's not a bad, well, actually, it is when I say it's not a bad excellence question, I mean, like it's a nice proof question, but the answer schedule actually gives a couple of long methods, and there's nothing wrong in having a go at a method like this as well. Yeah, so that is basically it for this question. Yeah, so to sum it up, it wasn't too much of a complicated paper, fairly straightforward, well, long excellence questions, but the achieved in merit was definitely doable. Yeah, I was pretty happy with it. Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course, subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Good revision material. And as always, thank you for watching.